A language that a machine can understand.
Okay. The language which is understood by a machine, and it is binary language, right? So binary number codes are understood by a specific CPU. So different, as you move from a different processor, one processor to another, then hardware specification of that processor might change. So that is native to that processor itself. The language is native to that processor itself. Across several families of processor, it is slightly different. The way in which data is represented is different, although it is binary, but the way in which it is represented. For example, a number can be stored from left to right. Suppose I'm talking about memory. So suppose I'm talking about this number 20. Okay, I want to store this number in memory, right? So first of all, this is a decimal number. I need to convert into binary. So what is a binary equivalent of 20?
Hello, ma'am.
Yes.
Ma'am, only your first slide is visible, ma'am. We can't see anything you are writing or.
Okay. Okay. I'll share it again. Just a minute.
Yeah, ma'am, visible.
Just a minute. Now it is visible.
Yes,
Yes, ma'am.
ma'am.
Yes, ma'am.
Yeah. So when I talk about a number 20, okay, can you see what I'm writing?
Yes,
Yeah.
ma'am.
Yeah. So when this number, I am representing this number in binary. So what is a binary representation? Can anyone tell me?
10100.
10100. Everyone agrees? I don't know whether everyone knows how to convert it into binary. Anyways, this is the number. Yeah, 10. It's correct. 10100. Okay. So when I'm representing this particular number in memory, when I I could represent this number from left to right or right to left. So some architectures represent it, save it from left to right. Okay, in memory. Okay, and some other architectures might save it in the other way. So I might, if I'm following the right to left convention, then I might write it something like this. Okay, and this is 20. Okay, but if I'm talking about left to right convention, then it will be the usual way. Okay, so it depends on the architecture that the processor is using. Machine language is binary, but it will change from processor. The representation of that data will change from processor to processor. Okay, so that is machine language, that is zeros and ones. The next type of language is assembly language. Okay, now assembly language is a little level higher, I can say, than machine level language. It's a level higher than machine level language, uh, and it includes special codes called as mnemonic codes. Okay, so mnemonic codes basically are uh, acronyms basically for machine language instructions. Okay, so suppose so basically these assembly languages, they form part of microprocessors. Have you heard of microprocessors? 8085, 8086. There's a family, different types are there. Okay,
Yes, ma'am.
8085, 8086. So assembly level language forms part of microprocessors, and it uses mnemonic code. So if I want to write something to represent addition, I want to add two numbers, then I use a mnemonic code like add. Okay, so it's a short form. Okay, and there'll be some equivalent number which will represent this, something like 1 2 3 4, which I'm going to key in into my microprocessor, that something like that. Okay, so I say add a comma b, something like that. So the instructions are very short and sweet, which are easy to understand when I look at it, when a human being looks at it. Because see, when I as a human being code, I cannot code directly in binary language. You know, I will not make sense out of it, 0 1 0. I mean, it will be very difficult. Now, if I instead of add and subtract, suppose I have add subtract, this will be easy for me to understand, right, intuitively. But if I write something, my add means 1 0 1 0 and subtract means 1 1 0 0, something like that, I cannot correlate well with this. I cannot because I'm not used to using binary language, right? So that is why instead of using the machine level language, we go for a better language which we understand. Okay, so assembly language is still lower as compared to the high level languages that we have, like C and Java, all these languages. Okay, the set of instructions that they have are relatively simple. So add, subtract, they can perform relatively simple operations, these languages. Okay, next we move on to high level languages. High level languages are the languages that we are going to look at all through the courses where programming is involved. Okay, so the language, of course, high level language, it has some English symbols, so it has some English symbols which are there, and there are other algebraic expressions which are used. So it's a combination of English symbols and algebraic expressions. So you will find somewhere some English language symbols, but there are operators as well. So you must have worked with this, right? Plus, minus. These operators you must have worked, right, in the first program in C. So you can write an expression. Am I audible? Can you hear
Yes.
me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Thank you. Yeah. So plus, minus, star, all these are operators, and using these operators, mathematical operators, you can write expressions, algebraic expressions. So high level languages are actually machine independent programming languages which combine algebraic expressions and English symbols. Okay, so they are independent of the machine, so we are not bothered about what is going on behind the scenes, right? How it is being translated and all. We are just bothered about understanding how to write our program in that specific language, how to translate, write those instructions in that language, and in our case it's going to be C. So this gives a list of high level languages like Fortran, COBOL, Lisp, C, Prolog, C++, Java, Python. Okay, so all these are high level languages. Now when actually we write any high level language program, this particular flow tells us what are the stages, right from starting from writing the program to executing it. What are the stages, intermediate stages that come up in between? So of course you're going to write a program using an editor or the word processor or an editor, right? So it is used to type in your program. So any editor you can work with depending on what type of operating system you're using. And there are many editors which are available which can be downloaded on your system. Once you type that program, okay, you have to save it with an extension. What is the extension for a C program?
.c.
Dot C.
Right? So the program is saved with a .c extension, and this particular program actually is known as a source file. Okay, the code that you write in any language, it could be Python, it could be Java, it could be C, C++, any language that you write, and once you save it with that language's extension, that code is known as a source code. That program, that file is known as a source code or the source file. So once this source file is ready, you have written your entire logic, your program is ready, you save it. Next step is you compile the program. So for compiling, you already know that compiling is done with the help of a compiler. And what is a compiler basically? Of course, the program has to run ultimately on the processor, right? So you need to convert that language to the machine level language. Okay, the high level language to machine level language. So a compiler is nothing but it translates. It's a translator program. It's a translator which converts that into machine language code. Okay, so for C we are using the compiler GCC. Okay, what is GCC? It is GNU compiler collection. GNU compiler collection. So it's an open source distribution of the C standard, the language standard specify which pertains to C. Okay. Now standard, I mean to say, of course, it was founded. The language was founded, and then there were some iterations and there were some changes. So it is standardized, and what I can do is any compiler. So if I'm talking about a language, C, it's an open source language. I know the syntax. So any company can come up with a compiler. You can also come up with a compiler which follows the standard of C. The standard, that means whatever rules are specified in the C language, accordingly your result should come. So you write a program, it should work, it should compile, it should get compiled, it should run. So you can create your own compiler if you know how to create it. Of course, we are not going into that, but it follows the standard which is specified by C. Now there are different standards. There were different revisions, iterations. So latest is C99 standard. Okay, you have C80, C89. These are the standards. There were some changes, slight modifications to make it better. In every standard, basically there's a revision of the language. So where the basic syntax remains the same, but some functionality is a bit modified. Okay. So latest is the C99 standard. So this is about the compiler. Don't worry much about it. As we progress, we will understand what kinds of, and as you also search through different resources online, you will find about this in detail. Okay. So once I write this and give it to the compiler, there are two possibilities. Either your program is very well written, it is following all the syntax correctly of the C language, so it is successfully compiled, right? Or the other option is it is unsuccessfully compiled. Why? Because you have made some syntax errors, you have made some mistakes while writing the program. Okay, and that is an error, right? So you have made what is known as a syntax error. Okay, have you heard of this term, syntax error?
Yes, ma'am.
Grammatical mistake.
Yeah. So syntax error basically is you are not following the syntax of the language. You are not following the rules which define the language. So for example, in C language, every statement that I write, every executable statement that I write, one of the rules is it should end with a semicolon. It is a statement that I'm writing, whatever it is, x is equal to y plus z. This is a statement that I'm writing, should end with a semicolon. If I forget to add this semicolon, okay, then I have not followed the rules of C. I have not followed one of the rules of C. So that is nothing but I'm not following the syntax correctly, right? So this is known as a syntax error. So if I forget to add the semicolon, even by mistake, it's still an error. C is very strict, the compiler is strict. Will not forgive you. Okay, so what happens is unsuccessful compilation happens, and you are given some error messages. So I think most of you who must have run the program, some of you might have typed correctly whenever the instructor was telling you to type or sharing the screen with you. Okay, but some of you must have made a mistake, right? You must have forgotten. This is a very common error, by the way, forgetting the semicolon, right? So if you go back to last week's lab session, you might have made this mistake. So what happens? Some error message in line number this expected semicolon before this line, right? You must have seen this error, some of you. Okay, and it's good to make errors
Yes.
initially. Yeah, because you come to know about the errors. Yes. Okay, so make those errors, I suggest, rather than copying it directly. Just forget it. Just remove that and see what happens. Okay, so that gives you an error message. So if your error message is given back to you, you cannot proceed because the file, in fact, that is created as an output of the compilation. So what happens is compiler creates a new file actually. When you give it to the compiler and your program is error free, a file is created, a separate file is created. Okay, otherwise it will not be created. So what if it is not created? You need to make those changes such that it is error free. You need to find out your errors. Okay, this is prompting me, there's a semicolon I have forgotten. I'll put back my semicolon and again save my program. So once that is done, is if my compilation is unsuccessful, I make changes. So it's an iterative process. I keep on making changes till my compilation is successful. Okay, and once my compilation is successful, then what I get is a new file, and that file is known as an object file. Okay, so in fact, this object file, the format of this file is in binary. Okay, and you're going to use this file to actually run your program. Okay, the object file is used to run the program. Okay, so this file uh, is that you have in case of GCC is a.out if you're looking for a Linux environment, and in Mac as well. And this file by default, it has a name by default, that is a.out. Although you can change the name, you can give it a new name. Okay, this can be done, but for now we'll talk about the default only. The default file name is a.out or a.exe if you're talking about a Windows platform. Okay, so a.out or a.exe, and you need to run this file. Okay, so that your program gives you the output. Now what do is to run this file, basically now instead of one file, it might happen that you're writing a full-fledged application in C. Okay, so in a full-fledged application, your code will be distributed across several such files. Okay, so far we have seen only one file. In all our programs, whatever we discuss, we'll be seeing only one file. But if at all you happen to do a project which is involved in C, then you will be having a list of such files, an entire folder which will have all your source code files, and then of course you have to compile all those source code files to form your object files. Okay, so 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 you will see one entity called as a linker which comes into picture if there are multiple object files. Okay, but for now we are not going to look at this because we are dealing with one file. Maybe later in the course I will tell you how this works. Okay, so for now just forget it. So there's this entity, what it does is it combines multiple object files together. Okay, uh, and then it forms your executable file, final executable file, which is actually run. Okay, which is actually run by the loader. So loader is another program again which comes into the picture, which actually copies your executable file into memory, and it starts the initiation of your it does the initiation of your instructions. Okay, execution of instructions. So these are the steps for entering, translating, and running the high level language program. Okay, I've explained all of this. and IDE, which you might well install and keep on your system, like IDE for C could be code blocks. Okay, but right now do not use it. Later on, as we learn the syntax majorly, you can start using this. Okay, so IDE is integrated development environment, where I had also highlighted about this in our very first lecture, that common lecture that we had, where it is a package, it's a complete package of a word processor, a compiler, and different tools for finding errors. Okay, so debugging and all can be done, right? You need to find out that those bugs
Ma'am,
which
can
are there
you
in your
tell
program.
about the linker again? I confused about it.
What linker?
Yes.
See, the linker comes into picture when there are multiple object files which are there. Okay, so it will link multiple, it will form a complete one single executable, because there are multiple object files which are scattered in your system for your application. That will happen when you have a full-fledged application. Okay, so all these object files, it will combine, and whatever are there, whatever is there, code is there, it will try to resolve all those references. So there might be that you are having one function in some program, which some file which you are using somewhere else. So all these are known as cross references. So it's going to try to resolve cross references. So that is why I'm not going into detail, because I'm not talking about multiple files as of now, right? I'm talking about a single file which I'm going to run. Okay, so that is what I'm saying. If I go, when I go further, I will definitely give you a program example where I'm using multiple files. Okay, fine.
Yeah, thanks.
Next, we move on to the C language elements. The first one is the preprocessor. Okay, so again, preprocessor is yet another program, a system program, which modifies the text of a C program before it is given for compilation. Okay, so actually when it is given for compilation, before that there is one more stage which is known as the pre-processing stage, where there's some sort of pre-processing done, and that pre-processing is performed by another program which is known as a preprocessor. Okay, what it does is basically it's going to modify the text of the program in such a way so that it can compile successfully. Now why it is required is because there are some files which are there in the C library, the standard C library. They are known as header files. Have you heard of header files?
Yes, ma'am.
While doing your first practical, you must have used.
Yes.
Yeah. So these header files basically need to be included. So why do I need to include? Because I need to use some functionality from the header files. For example, if I want to print something on the console, or if I want to read something from the keyboard by the user has to enter something for the program. Input data has to be entered by the user. Then in that case, there is one header file. What is the name of that header file?
IOStream.
stdio.
Standard
Yes,
IO.
yes. So preprocessor is going to actually include that part of the code from the entire file into your program, so that you can use those functions which are available, okay, as part of the C library. So the library that is there in C, that is basically the header files. The set of header files which are available in C is the C library. It's a collection of useful functions and symbols which can be accessed by the program. Okay, each library has a standard header file. Okay, and this printf and scanf, it is stdio.h. Mathematical functions, there it is mat.h. Okay, so all these header files are nothing but standard C library, which is functions which are available directly. You can use it. The functions are defined. You just have to use it to your convenience. Okay, so preprocessor directives. So the preprocessor you have heard of, the library you have heard of. What is a preprocessor directive? It will instruct, or it will instruct the compiler. Before the compiler, it will add some lines of code which you have not written. You have just written the line to include that code. What is that line? Hash include. You have written hash include stdio.h. Okay. So the preprocessor will actually add those lines for you, which are required by the program. Okay. So the commands that provide instructions to the preprocessor are known as the preprocessor directives. They are commands, they are directives. Hash include is a command to the preprocessor, right? It's a directive. It is telling, it is instructing the preprocessor that look, that I need this file stdio.h in my program. I need this file mat.h in my program. Okay. And there are others. Okay. So hash define is one more preprocessor directive which is used for creating constant values usually. So constant macros in your program. So hash include is for this. For example, stdio.h printf scanf hash include, this is done. And hash define is for data values, for defining data values which never change. Okay. So for defining constants in your program, we make use of hash define. For defining constants in your program, values which never change. So for example, what is a value which never changes? For example, if you have some kind of a conversion factor in your program. So for example, kilometers per mile. So I want to define this conversion factor in my program as part of my program. So I define this and I know it's never going to change. Okay. What is kilometers per mile? How many kilometers are there in 1 mile, right? So that is fixed. That's a constant, right? So if I have a constant in my program, the general practice is I define it using hash define in C. Okay. So it's basically used for defining constants. Okay. It's called a constant macro because there is a constant keyword, const, also in C, which I'll talk about later. Okay. So macro means whatever you have written here, okay, in hash define, whatever you have written here, if this particular name comes up somewhere in your program, down, of course it will be there, right? It's a conversion. Somewhere there'll be a formula which uses this. If it's a conversion, there'll be a formula somewhere in my program which will use this conversion, yes or no? We'll use this value, no? To convert into miles. Maybe I am given to convert into kilometers, sorry. So suppose I am given 100 miles. I want to find out how many kilometers are there in 100 miles, right? So I need to multiply it by kilometers per mile, yes or no?
Yes, ma'am.
Yeah.
Yes,
So
ma'am.
whenever this term comes down, it's going to replace it by that value which is written. Whenever this term comes down in my program somewhere, it will be replaced it by that value, constant value, whichever is written. So it's hash define space macro name, and by default everything is in caps. Okay, this is a convention. By convention, the constants in my program will be written in all caps. Okay, it's a convention, it's not a rule. I can use small case as well, but the convention is to use all caps. Okay, space the constant value. Okay, this is the syntax that you have to follow. Hash define constant name followed by the value, space, and then the value. Okay, constant macro, constant value. Then we come to
Ma'am,
comments. Yes.
can you explain that once again? Last part. This slide.
In your program, you will have multiple places where you require. So mostly, whenever you're working with programs which involve conversions or formulae, lots of formulae, mathematical formulae, right? For example, if you want to compute area of a circle, what do you have? What is a constant involved?
Pi.
Pi.
right? So yeah, which you're going to use multiple times. So it is very, every time I have to write 3.1416 or whatever value I like, I'm writing 3.1416. It is up to you how many decimals you want, whatever you want. Okay, so it's very cumbersome. It's bad, right? Again and again I have to write 3.14 everywhere in my program. I do not want that. I make it, look elegant. My program look elegant. I also like to write it, using English rather than using 3.14 every time in my formula. So suppose I have in my particular program, area of a circle, perimeter of a circle, okay, and multiple such formulae which are involved. So instead of using 3.1416 every time, I will use pi every time. So if I have a formula, so what I'll do is, first thing is I will define my constant pi using hash define. I'll say hash define the constant pi, correct? And I'll define my value. Where will I define this? Before, at the beginning of my program. Okay. And then in my main function, right? In my main function, I'll have my formula. So suppose somewhere I have formula area. Area is equal to, instead of writing 3.1416, I'll write pi into r, right? So what will be happening in the background? This pi, since it's a hash define, when will this happen? This will happen before compilation, because this is the preprocessor stage, right? It's a preprocessor directive before it is given for compilation. Whatever hash include is there, that is taken care of. Whatever hash define is there, that is taken care of. So what will happen? The preprocessor in fact will do this job for you. It will replace wherever this pi is with this constant before giving it to the compiler. Okay, it will prepare your program, replace this with the constant, and then give it to your compiler. That is what this hash define is. Are you getting it? Whoever asked that question?
Yes,
Or
ma'am.
still?
Got it.
So, ma'am, there is no need of equals to sign there between pi and the value.
No. The syntax is hash define pi, constant value, whatever it is, that value has to be there. The syntax
Ma'am,
is this.
can you please show the hash include slide for 1 minute?
The slides, all these slides I'll be passing on to you, don't worry.
Okay.
Everything will be given to you. Okay. Next is comments, right? So comments in C basically are those which begin with a /* and end with a */. Okay, these are forward slashes, both of these. Comments are used to provide some kind of supplementary information, and they are ignored by the preprocessor and the compiler. So you want to make your code more readable, you can add comments. Okay, this section of my code is doing this job. Okay, because your code might have multiple such code segments where you might want to know later on, you might want to revisit your code, right? Or someone else wants to look at your code, so that someone else should be able to understand what your code is doing. Okay, so what you can do is you can provide that extra information to make it more readable using what is known as comments. Comments help you to structure your the understanding of your program. Okay, now there are these style comments. These are known as multi-line comments. So this is a comment, right? This is a comment, multi-line, end with this, right? There are also single line comments. And what are they? Have you come across single line comments?
Double slash.
Double slash.
Double slash.
Double slash.
Yes, double slash, double forward slash, right? So this is a multi-line comment and this is a single line comment. In the original standard of C, we had only single line comments, but as far as the new standards, latest standard of C is concerned, this is also allowed. This single line comment is a C++ style comment. It is a C++ style comment. It's not a C style comment. originally, but now both of them are allowed in the compiler. So you can use both, whatever you like. Okay, this is already, these are some examples. These are some examples. Okay, so I'm skipping it. Next is the function main. So this, we talked about the preprocessor directives, where your program actually, this flow which I'm taking you through now is actually how your program is structured. So very shortly we will see the diagram which depicts a typical C program. Okay, so this is the main function. The main function is it comprises of two parts. One is declarations and second is executable statements. So the declarations basically tell the compiler the names of memory cells in a program. Okay, so declarations is basically where you declare your variables, right? What is a variable, by the way?
Any named memory location used
That
to
is
Right,
store
to
some
store a
value.
value.
right. So your program is running in memory and the name of that memory is nothing but variable. So you give it an alias and that is a variable. Okay, and second part is the executable statements. So these are nothing but they are converted to machine language instructions which are executed by the computer. So basically these executable statements we'll see, which are written in the main program after main function after the variable declarations. So now the syntax is, you have int main is the main function, open close bracket, and then you have the curly brackets. Inside that you have the function body. So the example is the very first program you must have done, that is int main, where you're printing the hello world or some message. Okay, so that is how it is written. Now there'll be many questions coming from your side, like why this is int, can it be something else, or what does this mean? Okay, then this is return 0, what is the meaning of this? This meaning right now, it's very difficult for me to explain because you do not have the knowledge of functions yet. Okay, so just remember for now is the main function is a very important function, from where in a C program where the execution begins. Execution of the program starts from the main function. That is the first thing. So of course you can have some statements which are written directly, which are there in the standard library, or some formulae expressions directly in main, or you can call some other functions which you have defined inside main. Okay, so when we see functions, actually you will understand what is this int. Okay, it's basically it's nothing but it is known as a return type. Okay, so it is returning some value. What is the value that it is returning? You can see the statement, return 0. Okay, it is returning a value 0. So the return type is an integer. It's returning an integer. Okay, and to whom it is returning? It is returning to the calling environment. The function returns a value to the calling environment. Some functions return values, some functions do not return values. Okay, what is a function, by the way? In layman terms, function is basically a block of code, right? It's a block of code which performs some task, right? It's a block of code which performs some task, gives you some functionality. That is nothing but a function. Okay, so main is a function which you are defining. Actually, you are defining the main function. Okay, and inside main, what you have used here, printf. Printf is also a function. Printf is also a function, but you are not defining it. What you're doing is you are calling it. You are calling the printf function. Okay, so there are different terms which I have now just thrown to you: defining, calling. Okay, all these mean different things. Okay, so when we actually talk in depth about functions, you will understand why int, why return 0, what is the meaning of that. Right now it will not be the right time to explain what it is. You will not get it. Okay, so this is explained here further, so whatever I said, but you won't understand much of it right now. Okay, and of course these are the parentheses which are there, no? The round brackets. You will find these are the parentheses. You will find it in every function that is there. So this printf is also a function. You will find parentheses after it. So that's the syntax of C, that after every function, if you want to pass some data to a function, you want to pass some data to a function on which it will work, because the data, your function is going to work on some data most of the times, and that data is passed through it inside the parentheses or the round brackets. Okay, then we come to the concept of reserved words. Okay, so the reserved words basically are some special words, words which have a special meaning in C. Okay, these are some reserved words which are there. Reserved means it is reserved especially for C, particularly for C. You cannot reuse them. You cannot use these words in your program. If you try to use this word as your program, as your variable, so if I have a variable name like int, it will not allow me to use it. It will be a syntax error because this is reserved by the language. Okay, so int, void. So void is something which is there. You must have seen in some examples somewhere, void main. Have you seen?
Yes, ma'am.
Yeah. So void is a special type actually. Void is a special return type, which means that nothing, no data is going to be received from this function. You're not expecting anything in back to be returned by this function. So void is a special type. Okay. Then there is double, there is return. All these are reserved words. You cannot use them as part of your variables. Please switch off your microphone. Who's that? Okay. So these are the reserved words which are there. Then you have something known as standard identifiers. Okay. So standard identifiers have special meaning, but one that a programmer may redefine. So you can have uh, printf and scanf as variables in your program, but it is not recommended that you have. So it will not give you an error, but it is not recommended because the program might not behave like you intended it to behave. The behavior of your program might be undefined if you use it, because see what will happen is, suppose if you have a variable named printf. So suppose how do I define a variable? I have not come to variables yet, but you have used it anyways. So in printf, and somewhere down I use printf, then it does not make sense. Now printf hello world, whatever. So it's best not to redefine them. It's best not to redefine. Then I am printing printf hello world here somewhere %d, and then I'm trying to print printf. Okay, why are you confusing yourself? No? You can try all sort of anomalous behavior here. You can try, okay, breaking the language, but then you might yourself be confused, because that is not the way that you write a program. Your program has to be concise. It has to be clear. It is not something like it's so difficult for you. Later on when you will open, you will only forget what you have written. That should not be the case. Okay, this is not a good programming style. So it's recommended not to redefine them. Okay, standard identifiers are basically those function names which are there, which you should not use them. So in the standard input output library, there are functions, there are some other functions in some other header file. All these are standard identifiers. Do not use them. Although you can use them, do not use them. Okay. Next is user defined identifiers. So user defined identifiers basically are nothing but your variables. They are known as identifiers. Now identifiers are not only used as variables, they are also used for defining functions. That is why we have said user defined identifiers. User defined identifiers basically can be variables that you write in your program, or they could be functions that you define, user defined functions. So I want to write my own function, print my name, my own function. Okay, I can do that. That is a user defined function, print my name. This function is not present in the C library, standard C library. It's user defined by me. So what are the rules? What are the rules for writing these, using these identifiers, for creating these identifiers of your own? Okay, so these are the rules. So it must consist of letters, digits, underscores. It cannot begin with a digit. Reserved word cannot be used as an identifier. Okay, you know all these rules, all of you?
Yes, ma'am.
Because the first program you have done. So
No,
I
ma'am.
think the rules. Okay, some of you might not be aware of all the rules, but these are the rules. So suppose you have the variable. Your variable will not start with digit. It will consist of letters, digits, underscores only. It cannot contain a special character like hyphen or star or something like that. Reserved word cannot be used as an identifier. I told you already. Int. I cannot have something like int. Int is a reserved word, right? So I cannot create a variable int. This is not allowed. Wrong. Okay. An identifier defined in a C standard library should not be redefined. Okay. So what is the meaning of this? Identifier which is there, like printf is not an identifier. It is an identifier, but it's a function identifier. Okay. There are some constants also which are defined in the library. In fact, pi is also defined in the math library. This function, this constant. Okay. You should not redefine it because it creates confusion. Okay. Because if you use that library, then it creates confusion. So don't unnecessarily redefine it. But the first three applies for identifiers in general, that letters, digits, underscores allowed, special characters not allowed. Okay. It cannot begin with a digit. It cannot be used as the reserved word cannot be used as an identifier. So these are the examples. These are all invalid, and the reasons are given on the right hand side. Just go through this. Are you getting all the five examples?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So this actually gives you a picture of the reserved words versus the identifiers which are there. So it's everything that we discussed so far. So reserved words on the left hand side, middle column is the standard identifiers which are there, and user defined identifiers are given on the right hand side. It's fine. And this actually is a picture of a C program, which is a kilometers per miles. It converts the distance to kilometers, right? So it gives you actually all the elements of the C language. Okay. So before we actually start any programming, it is important that we understand the elements of the C language. That is why I had to go through this. And I know you might be, waiting for some program, but I cannot just jump to a program. I have to talk about this in the beginning. Okay. So you can see here that these are preprocessor directives. We talked about preprocessor directives. We talked about macro constants, right? This is just a revision of sorts. These are variables. Okay. These are standard identifiers. This is a reserved word again. This is a reserved word. Of course, this is also a reserved word. This is also a reserved word. Can you see? Double int. I'll come to this. This is just giving you an overview. I have not talked about anything in detail. Don't worry. Okay. This is the standard header file. These are comments. So everything in a nutshell, it is giving you everything together. Okay. These are punctuations. These are some special symbols. We'll talk about this. Okay. So I will stop right now. And we'll continue this discussion in this week only in the next lecture, either tomorrow or mostly tomorrow. Okay. Where we talk about some more examples I'll be going through of the language, and I'll be sharing these slides to you when I finish that lecture, tomorrow's lecture. Okay.
Ma'am,
Yes.
ma'am, where we are going to get the all recordings of the previous lectures?
The recordings are not visible to you
No, ma'am.
No,
No,
ma'am.
ma'am.
on the drive, on your Google Drive. Is it not
No.
visible to
No,
you?
ma'am. No, ma'am.
Okay, then
No,
what I
ma'am.
will do is, so I'll be sharing at least my recordings. I'm going to share on Google Classroom. So I'm creating a Google Classroom and adding all my recordings there, and adding you to it. Fine.
Yes, ma'am.
Okay, ma'am.
Thank
Thank
you.
you.
Yeah.
Okay, ma'am. Thank you, ma'am.
Yeah.
Okay, ma'am. Thank you, ma'am.
Thank
Yeah.
you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.